Hi students, good afternoon everyone. This is Ramsur, your maths faculty. I welcome you all to Turito live classes. So children, today we are going to discuss like previous class only, but it's the continuation of previous class. Okay. Children, let us start today's class. Children, in the previous class we have learned about the what? The fundamental theorem of arithmetic, and next the introduction of LCM and methods of finding the LCM. Children, we have totally 3 methods of finding the LCM. That is the what? Listing the what? Writing all the multiples of the number. And second method is by prime factorization method. And third method is what, children? Long division method. Okay, it's like division method, like finding the all the factor. Okay, so these are 3 methods we have exactly for finding the what? LCM. And we have discussed some problems related to what? Finding the LCM for the different kinds of numbers. So that was the previous class, children. Okay. Now, children, today's class we are going to discuss about first one, introduction of HCF. Next one, the relationship between the HCF and the LCM. And some problems we are going to discuss about how to find the LCM, like LCM and HCF, and the relation between the both of them. Like he will give something HCF value, and they are given the what the product of the two numbers. Like we have some kind of problems. So those kind of problems we are going to discuss today, children. Are you ready, everyone? Yeah, very good. Now, children, can you tell me what is the HCF? So, what is called HCF? So, what is the full form of HCF generally? Any idea, children? HCF means what, children? Any idea? Children, HCF means what? Generally the highest common factor, isn't it? Otherwise, HCF also we can say sometimes GCD also. GCD means what, children? The greatest common divisor. You can call it as HCF or you can call it as GCD also. So both are same, but the using terminology is different. You can call it as HCF or you can call it as GCD also. Both definitions are same and both values are same only. Okay. Now children, let us say what is the definition of HCF now. The highest common factor. Children, what is the meaning of HCF here? HCF means the highest common factor. Highest means what, children? Here the greatest one we can say. Okay. The highest common factor, okay, of two numbers is the highest possible number which divides both the numbers completely. Children, we have to pick up the word the greatest common factor, and that should be what, children? Divides both the number completely. Here completely means what, children? Here like we have to get the 0 as a remainder. So that is called what? The complete division. Am I clear, children? What is the definition of HCF? HCF means what? The highest common factor. Okay. So among all the factors of 2 or 3 numbers, we have to what? Pick up the greatest one. So the greatest factor we can say highest common factor, or we can say GCD. That is greatest common divisor. Clear, children, this point, everyone? Yes. See, the highest common factor, I told you, children, just now, the highest common factor also, what we call? We can say GCD also. You can call HCF or you can call GCD, both are same. So we can say the greatest what, children? Common divisor. You can call as what? HCF. You can call as HCF or you can call as GCD. HCF means highest common factor and GCD means greatest common divisor. So both are same. The only thing is what, children? The names are different. Okay? But meaning is same. The finding the value also same. You can call it HCF or you can call it as GCD. Clear, children, everyone? Regarding the definition or any doubts? Definition is very simple, children. I told you already. We have to pick up the word the greatest factors among them. So that is called what? GCD or we can say HCF. Clear, children? Any doubts? No. Very good. Now, children, let us have, first we'll take one small example, children. Then we can discuss like how we can find the like HCF or GCD, anything. Okay. Now, I am taking the small question, children. I want to find the HCF of what? 30 and 45. I'll go first basic method. So what is the meaning of basic method? By listing all the factors of the 30 and writing all the factors of 45. From that we will pick up the what, children? The greatest one, isn't it? So that is actually what basic method. As per the definition, that is the basic method. Okay, now what I am writing, children? I am writing the factors of 30. Children, do you know what is the meaning of factor? Tell me, children, what is a factor? So I am writing factors of what? 30. Tell me, children, what is the meaning of factor? Factor means what? If a number divides another number. Okay, so without giving any remainder, otherwise giving 0 as a remainder. So that is called what? A factor of the number. See, you can take 6 is the factor is what? A 30. And 6 is the factor is what, children? We can say 36. And 6 is the factor is what? 60. Because this 6 divides the 30 and 6 divides the 36 also, and 6 divides the what, children? 60 also. Isn't it? So we can say this 6 is a factor of 30, 6 is a factor of 36, and 6 is a what, children? Factor of 60 also. Clear, children, this point? Yeah, very good. Now, can you tell me, children, what are the factors of 30? So, how many factors exactly 30 has? Is it finite or infinite? Tell me, children, how many factors you can write? You can write finite. Finite means what? Countable. Infinite means uncountable. So, how many factors you can write for the number 30? 2, 3, 4, 5 are uncountable. Think, children, how many factors we can write for a single number? The number is what? A prime number. How many factors you can write? The number is what? Something, a composite number. So, how many factors you can write? Any idea, children, regarding these two? If a number is a what? A prime number, you can write exactly 2 factors. That means the number and 1. Like I am taking the prime number is something 5. So what are the factors of 5? We can write as 1 and we can write as 5. You can write as only 2 because 5 is the what, children? It is a prime number. So prime number means it has exactly 2 factors. That is the definition of a prime number. Now, this 30 is not a prime number. 30 is what, children? It is the composite number. So, you can write more than 2, isn't it? Now, I am writing the factors of 30. So, I can say 1 divides. I can say 2 divides. 3 divides. And 4 won't divide. Okay. And 5, yeah, 5 also divides. 6 also divides. 7, no. 8, no. 9, no. 10, yeah, 10 also divides the 30. Next, 11. 11 also, no, it is not possible. So, I can go directly 12, 13, 15 I can take, children. Because 15 2 times 30. So, 15 is a what? A factor of 30. 16, not possible. 17, 18, 19, so directly I can go for 30, children. Because every number is what, children? Factor of itself and multiple of itself. So, children, I am writing all the what factors of 30, that is 1, 2, 3, 5, 6, 10, 15 and 30. Okay. Now, I am writing the factors of 45. Now, tell me, children, factors of 45. Tell me, what are the factors of 45? How many factors you can write for the number 45? Can I say 1 is a factor? Yes, we can say 1 is a factor. 2, no. 3, yes. 4, 5, yeah, 5 we can say. 6, not possible. 7 also, no. 8, 9, yeah, very good. We can say 9 also factor. Next, 10, 11, 12, 13, 14, 15 we can say, children, because 15 3 is a 45. So, 15 is a factor. Next, 16, no. 17, no. 18, no. 19, 20, 21, 22, 23. So, directly we can go which number, children? Shall we go directly 45? Isn't it? We can go directly 45 only. Okay? So, 45 is the what? The last factor of what? A 45. I told you just now, every number is factor and multiple of itself. Now, children, look at this, all the factors of 30 and all the factors of what? 45. Now, what I am doing? I am just rounding off all the common factors. See, I can say 1 is a common for both the numbers. So I am rounding off. Next is what, children? What is the common of both the numbers? Just look at this. I can say 5 also common. Isn't it? And next one, children, I can say 15 also common. Okay. So I am writing now common factor. So tell me, children, what are the common factors I am writing? 1 is a common factor, 5 is a common factor, and 15 is a common factor. Isn't it, children? Now, what is my question? Out of this 1 and 5 and 15, so can you tell me what is the greatest one? Like which number is greatest among the three numbers? 1 or 5 or 15? Tell me, children, 15 is the greatest one. Don't you know comparison of numbers? Yes or no? So we can say 15 is the greatest number. So we can say 15 is HCF. So I can say 15 is what, children? HCF. Or we can say GCD. You can say HCF or you can say GCD. Okay, both are same. See, children, any doubts regarding this? It is the first one is a first method. Otherwise, we can say basic method for finding the GCD, or we can say HCF. Any doubts, children, regarding this? Okay, fine. Next one, children, methods of finding the HCF. Children, here also we have exactly 3 methods. So what are the 3 methods? See, we have exactly 3 methods, children, here. The first method is, tell me, children, what is the first method? Any idea? The previous method, just now what I have done the problem, the solution, that is what? A basic method, listing all the factors, isn't it? So I am writing HCF by what? Listing all the factors. So it is a method number 1. Okay? And second method, by prime factorization. It is what? Second number, sorry, method number 2, like second method it is. And next method is what? HCF by what? A division method. Here also we have something division method, children. By using the division method also what? We can find the HCF of any 2 numbers or 3 numbers. Okay. So these are the 3 methods, children, we can use. But generally, children, we can go for this second method or you can go for third method. Okay. The first method is not very useful at this stage because you are in 10th class. So generally this method will done by like small kids. If you are in something 6th class or 7th class, so at that time okay. But you are in 10th class, so my suggestion is either you can go this method or this method. But mostly we have the problems on third method. Okay. The first method, second method is expired for you, children. So don't go for that method. Better you go for only division method. But still, I will explain this what is first method and second method. See, first method already done. I already explained you by taking one example. Okay, the same way I will explain the second and third one. Okay, children, let us see the first method. So, what is the first method, children? HCF by what? Listing the factors. Okay, it is the first method for what? Finding the HCF. Let us see, children. Actually, what is happening in this method? See, in this method, we list all the factors of each number, isn't it? We list the what? All the factors of each number. Then we can find the what? The common factors among them. That is the first step. After finding the common factor, what we will do? Listen here. Among the common factors, we determine the highest common factor. That means we will identify the highest common factor. So the highest common factor is what, children, here? HCF of the number. Clear? First we will write all the common factors, like first we write the factors of both the numbers. So from this we will take only what? A common factors, not all again. Okay. We are taking only common. Common means what, children? The factor present in the both the number. If the factor present in the both the number, so that is called what, children, here? Common factor. Okay. Now, children, I am taking a small example. See, I want to find the HCF of 60 and 90. Okay. First method. Now, I am writing all the factors of 60 now, children. I am writing all the factors of 60. Now tell me children. So I can say 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor. Can I say 5 also factor, isn't it? 5 also divides 60. Then I can say 6 also factor. 7, 8, 9, I can say 10 also factor. 11, no children, not possible. Can I take 12? Yes, 12 also one factor. Next to 13, no. 14 also no. We can take 15 because 15 4 is a 60. Isn't it? And 16, no children. 16, 17, 18, 19. We can take 20 because 23 is a 60. 21, 22, 23 not possible. So we can go directly 30. After 30, I can go directly 60. Clear children? These are the factors of 60. Like 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30 and 60. Okay, these are all the factors of 60. Now children, I am writing all the factors of 90. Now tell me children, what is the factors of 90? Now we'll start from again same. So 1 is a factor, 2 is a factor, 3 is a factor. Children, can I say 4 also factor? 4 is not a factor. Okay, we can go for 5 also factor. Can I say children 6 also factor? Can I say 6 is factor? Yes. Just divide. 6 how many times? 15 times. Yes or no children? We can say how many times? 15 times. And sorry, you have to write 6 only. Yeah, 6 is a factor. And 7? No. 8? Tell me children, 8 is factor? 8, no I think. 9? Yes, 9 tens are 9. So we can go 9, we can go 10, 11, 12, 13, 14, 15, 15. Tell me children, 15 table, see 90 will come? No. 16? No. 17? No. 18? Yes. 18 is possible. Yes or no children? Children, is 6 is a factor? Check it once again. If 6 is factor means I can say 15 also factor, isn't it? We are missing the 15 number. So write down the 15. After 15, 18 will come. 18 5 is a 90. Okay. And 19, 20, 21, 22, 23, 24, 25, 26, 27. No, we can go directly 30 because 33 is a 90. Next, I will go 45. Next, I will go 90. Clear children? These are all the factors of what? Factors of 60 and factors of 90. Now, among them, just pick up the greatest one. First, I am picking what? All the common factors now. Now, tell me which is a common factor. So, 1 is a common factor, 2 is a common factor, 3 is a common factor, 5, 6. Next, we can say 10 is also common factor, 15 also common factor. We can take 30 also common factor, isn't it? Okay. So we can say children, these are all the common factor, but among them, what is the greatest one? So the greatest one is what children? Greatest one is what? 30. So 30 is the what? HCF of 60 and 90. Clear children? Any doubts regarding this sum? Question is very simple children. They have given the question is what? Find the HCF of 60 and 90. That's the question. So what I am doing, first I am writing all the factors of 60. Then I am writing all the factors of 90. Then I am selecting what? All the common. Like common means which are present in the both the numbers. From that, I am just what? Selecting the greatest one. Here the greatest one is what? 30 is the greatest one, isn't it? Therefore, what I can say children? 30 is the what? Highest common factor. Okay. Now children, let us go next sum, like next method. Okay, this is I think clear everyone, isn't it? Yeah. Now children, HCF by what? A prime factorization method. Okay. Now children, let us see how we can do this method. Now step by step. What is step 1, children? Find all the common prime factors given the numbers. We have to write only common prime factors, not all, children, only prime factors. Next one, then multiply these prime factors to obtain the what HCF of those numbers. Okay. And next one, that's it, very simple. First method is what? Step number 1, find all the common factors, both the numbers. Then separate it. After separating, what you are supposed to do? Multiply all. Okay. If you multiply all, you will get the HCF. That's it, very simple. What is there in the big deal? Isn't it? Separate all the prime factors and multiply it. So that is the what? HCF of those two numbers. Okay, let us do one question. Series question. I want to find the HCF of 200 and 300. First I am finding all the common factor, children. This is called what? A prime factorization. Okay, I'll go for directly 2 table. 2 how many times? 100. 2 how many times? 50. 2 how many times? 25. 5 how many times? 5 5s. So what I am writing, children? 200 I can write as 2 into 2 into 2, then 5 into 5. Now children, I am doing the factorization for 300 also. Shall I go 2 table again? Yeah. So 2 how many times? 150 times. Isn't it, children? 2 150 is a 300. So we can say this is 5. Next one, again 2 how many times, children? It is 75 times. Then I'll go 5 table. 5 how many times? 5 15s. Again this is what? A 5 3s. Okay. Now what I am doing, children? Again I am writing all the factorization of like factors of 30. Prime factorization. Tell me this. 2 into 2. Next 5 into 5. Next 3. Children, remember here, we are forgetting doing a small step, single step, that is a very, very important. Children, don't stop up to here 5. Okay. You take one more 5 here, then write 5 1 time 5. This is a very, very important step. Okay. Here also, don't stop it here 3 only. So go 3 table and 3 ones are 3. Here you can write as 1 time. Here you can write as 1. It is a very, very important, children, because sometimes you miss some values. Okay, I'll tell you why we are writing this one also. Okay. Now children, pick up the common factor. Here 2 is common. Isn't it, children? And one more 2 also common. And children, here only this 2 is present here, but here it is not missing. Isn't it? The second number, the number is 2 is missing. Only in the first number, second number, only 2 into 2, 2 into 2 is present. Here 5 is present, here also 5 is present. You can take this 5 and you can take this 5. You can take this 1 and you can take this 1, because 1 also what? A prime factor. You can take as a factor, okay? So 1 also factor. Then what are all the common factors, you know? Then what we have to do? Multiply all common factor, isn't it? So multiplication means 2 into 2. Next, children, you can write as 5 into 5, again into 1. So 2 2s are 4, 4 5s are 20, and 25 is how much, children? This is 100. Okay. So we can say 100 is the what, children? The highest common factor. Otherwise we can say GCD, greatest common divisor. So I am writing HCF. So that is highest common factor. See, children, question is very simple. Any doubts regarding this? I am just doing the what? A prime factorization of both the numbers. Then I am writing the what? All the common factors separately. After writing all the common factors separately, just multiply them. Simple. So after multiplying them, you will get some numbers. That is our final answer. Very simple. See, children, any doubts regarding this sum? No? Okay, that's fine. Next one, children, by division method. Children, I am telling you once again, only remember this method. This is a very, very important method, children. In the class 10, you are supposed to do only this method, all the sums. First method, second method, you just forget about it. Third method, what is the third method, children? division method. So this method is very, very important. Okay. Now children, let us see what is the division method step by step. Children, step number 1. So what is step number 1? In this method, what you are supposed to do, children, in this method? We divide the what larger number by smaller number and we'll check the what remainder. First we have to do what? Children, take at a time only 2 numbers. In the question sometimes they might be given the 3 numbers or 4 numbers also. So take at a time only 2 numbers and check which number is greater and which number is smaller. Then what you have to do? Divide the what? Tell me. Greater number by a smallest number. Suppose I have the 2 numbers, children. A is the 1 number and B is the 1 number. If you think A is what greater than B, will you divide A by B or will you divide B by A? Which is correct? We can say A by B is possible. B by A is not possible, isn't it? Because we can divide a bigger number by smaller number or smaller number by bigger number. We can divide what? A bigger number by smaller number only. Smaller number by bigger number is not possible, isn't it? So we can go for what? We'll divide the larger number by a smaller number and we'll check the remainder. Okay? Where the remainder is a non-zero number or zero number. So what is that? That we are going to check slowly. Then after that, what is step number 2, children? Then we make the remainder as the what, children? From the previous step as a new divisor. So we'll get the remainder anyhow. If you don't get the remainder, that stop it there only. In case if the remainder is a non-zero number, so what you have to do? So take that remainder as divisor for next step. Okay. And the divisor of the previous step become what? Dividend of second step. Are you getting my point, children? The remainder become what? A divisor for second step. And the divisor of first step become what? Dividend of second step. Okay. So that is the what? Step number 2. Again we have to do the same division. And divisor of the what? I told you. Divisor of the previous step become what? The new dividend. And perform the what? A same long division method. Okay. That is second step. But how long we have to do the same procedure? Isn't it? The same procedure we have to do till you get the remainder is what? 0. We continue the what? The long division process till we get the remainder becomes 0. Once you get the remainder is 0, you can stop division, children. So no need to do the division. So wherever you get the remainder is 0. So that divisor is what? Our HCF. Okay. So children, let us take a small example so that it is easy to understand. Now children, listen here. I want to find the HCF of 198 and 360. Children, see here they have given the only 2 numbers. So one number is what? 360. Sorry, one number is what? First number 198 and second number 360. Okay. So I want to divide, children, this. Can you tell me which numbers divides which number? 198 divides by 360 or 360 divides 198. Tell me, children, which is possible? So 360 divides 198 is possible, isn't it? 198 by 360 is not at all possible. Because 190 is a smaller number and 360 is a what, children? It is a bigger number. So we can write as 360 is greater than 198. Isn't it, children? Now, children, do the division here. So take 198 what? A divisor. And take 360 is a what, children? Dividend. Now tell me 198 how many times we can take? Like close to value or equal to value? 1 time or 2 times? So 2 times means, children, you will get 380 something, like 400 you will get. But 400 is not. It's a greater than of this number, so we cannot take. So we can take only 1 time, children. So 198 ones are 1. Now do subtraction, children. So this is 10 minus 8, it is 2. Here 6. 6 means what? 5 will be there. 15. 15 minus 9, it is what? 6. So here 2. 2 minus 1, 1. Okay. And children, this 162 become what? A divisor of second step. And this 198 become what? A dividend of second step. Now 162, 198. Can you tell me how many times? Tell me, children, how many times we can take? Again same, one time only. So 162 one time is 162. So 8 minus 2, it is 6, 9 minus 6, it is 3, 1 minus 1, it is 0. Again same children. So this remainder is what? Act as the what? Again divisor. And this divisor act as the what? Dividend. So I am writing 162. Now tell me children, 336 and 162. Can you tell me how many times we can go? 2 times or 3 times or 4 times or 5 times? What is the 5 times children? 36 into 5. We'll check it here. So 5 6 is 30, carry 3, 5 3 is 15. So this is 80. But this number is 162. It is not possible. So better we'll do one thing children. 4 times shall we go? Yeah. So if I take 4 times, 4 6 is 24, carry 2, 4 3 is 12. So this is 144. So we can take 4 times. 4 times means 144. So this is 12. 12 minus 4, it is 8. Here 5 remains children. 5 minus 4, this is 1 and this is 0. Now this 18 become what children? It acts as a divisor and this 36 acts as a dividend. So write down here 36. Now divide. Now tell me children, here 18 how many times? 36? It is 2 times. So 18 2s are, my answer is 36. Now here remainder is what? 0. Children look at here, I got the remainder is 0. At which number children? Which divisor? At 18 divisor. Isn't it? At the number 18 we got the what children? Remainder is 0, isn't it? So we have to stop our division. So you can stop it here. So here no need to continue. Are you getting my point children? Because I got the remainder 0, we have to start our division. Okay. So at 18 I got the what remainder 0. We can take HCF is what? 18. Clear children my point? Here this 18 is a what? Divisor. At this divisor I got the remainder is 0. So we can say 18 is what? HCF of this number. Which number? Like 198 and 360. See children, any doubts regarding this question? I am telling you children, try to learn only this method. Other 2 methods are not required children. This is only important. And whenever you are supposed to do, just go for only this method. Clear children, any doubts regarding this? Question is very simple, even method also very simple children. So we have to do the division till you get the remainder is 0. So once you get the remainder is 0, you can stop your division children. Okay, so that is our final solution. Okay children, any doubts? Okay, fine. Now children, HCF of multiple numbers. If we have the 2 number, that's okay. We can just take the bigger number and smaller number. We can do the we can go the what? A long division method and we can do it. Suppose if we have the 3 numbers, like multiple means what children? Maybe the numbers are 3, maybe the number for 4, isn't it? So at that case, how we can do this HCF? Like how we can find the HCF again? Do we have the same method or something different method? Tell me children. If you have something 3 numbers, in that case, how we can go and find? Will you follow same method or different method? If that is a different method, so can you tell me what is the different method? Children, I know only 3 methods, okay? But if you have some multiple numbers, maybe 3 or maybe 4, so in that case, how we are going to find the HCF? So that is my question children. Tell me. Okay, listen here children, not issue here, very simple. See HCF of 3 numbers. Here children maybe 3 or maybe 4 also. I am telling for 3. If you just understand for 3 numbers, you can do for 4 numbers, you can do for 5 numbers also. Okay. Then how we can do for HCF of 3 numbers? Listen here. In order to find the HCF for 3 numbers, we use the following procedure. Which procedure? Same again. So let us understand the steps again. One by one, we'll see children. What is step number 1? First find the HCF of any 2 given numbers. Children, out of 3 numbers, you can select any 2 numbers. So my suggestion is go for largest number and go for smallest number. Okay. So taking the smallest one and greatest one, find the HCF of both of them. Okay. After finding the HCF of them, then take that HCF Again that HCF and the second number. Out of 3 numbers, we have missed one number, so that number. So find the HCF again both the 2 numbers. So that will be the final HCF. Okay. In step number 2, what we do, children? Then find the HCF of third number. Okay. And obtain the first number 2 numbers in the previous step. First we will take the 2 numbers, greatest number and smallest number. We will find the HCF of both of them. By taking the HCF, what we will do, and that HCF and the, we missed one number, so that number, second number or maybe third number. So in between again find the HCF. So at last we will find the value, children. So this is what, that value is called our HCF of all the 3 numbers. Clear, children? Okay, children, I will tell you one thing. You can take A is a one number, B is a one number and C is a one number. You do one thing, children. First find the HCF of A and C. A is the smallest one and C is the greatest one. So HCF of A and C, you think it is a D number. Okay. So it is a HCF of A and C. After finding the HCF of A and C, again find the HCF of B and D. Here you get something E. Okay. So this E is a what, children? HCF of A comma B comma C. Okay. So this procedure you have to follow, children. And my suggestion is what? Better you go for what? The smallest one and the greatest one. Then find the HCF. After finding the HCF, again take that number and go for the number which we did not take. Okay. And find the HCF of the first 2 numbers and the leftover number, whatever it may be, second number or third number. So from that you find the HCF of A, B, C. Clear, children? Any doubts regarding this? Okay. See, children, it's a very simple, but same method we are doing again and again. That's it here. If we have only 2 numbers, means we can do only HCF one time we can find. But if we have the 3 numbers, then the same HCF will do for 2 times. So that will be our final solution. Clear? Okay. Children, let us see one small example. See, children, I want to find the HCF of 126, 162 and 180. Children, these are multiple numbers. It is not the 2 numbers, children. We have exactly 3 numbers. So for these 3 numbers, how we can find the HCF? Okay. Children, first tell me what is the given 3 numbers? 126, 162 and 180. Okay. Children, find the HCF of this number and this number. So 126 and division of 180. Tell me, children, how many times? We can go for only one time. So this is what? Take the borrow. This is what? A 4 and this is 7 minus 2. This is 5 and it is 0. Isn't it, children? So this is 54. And write down 162. Now 54 how many times? We'll go for 3 times. So 3 4 is 12, carry 1. This is 162. Here we got the HCF is how much, children? It is temporary HCF. Okay. Then take this 54 and take the 162. And find the HCF of these 2 numbers. Then you will get the permanent HCF. So this is 54 and this is 162. Now tell me, children, how many times 54 we can take? I can go for only 3 times. Again, this is 162. See, children, I got the remainder also here 0. So I can say overall HCF is what, children? 54 is the HCF. So this is our overall HCF. Clear, everyone? So we can say 54 is the what? Overall HCF. First find the HCF of greatest one and smallest one. Then you got some value, that is 54. And take the 54 and take the number which we missed in the first step. So that is 162. Again find the HCF of these 2 numbers. So that will be our final HCF, children. So we got the answer is what? 54 is our final solution. Clear, children? Are any doubts? Question is very simple, isn't it? Yeah. Now, children, relationship between the LCM and HCF. So what is the relation between the both of them? Okay, so that we are going to learn now. Okay, children, I am taking the two number. One number is A and one number is B, children. Both are what? A positive numbers. Then this formula, what is the formula? I am writing a formula. Suppose what I am writing, children, the HCF of A comma B I am writing as HCF of I am writing as A comma B. LCM of A comma B, children, I am writing as LCM of A comma B. Then what is the relationship, children, here? The product. Product means what? A multiplication B. We can write as, tell me, children, how we can write? HCF of A comma B multiplication of LCM of A comma B. So this is what? A relationship between the what? LCM and HCF. So product of the numbers we can write as HCF of that numbers and LCM of that numbers. So it is a what? A relationship between the LCM and HCF. Clear, children? Very simple, children. LCM into HCF is equal to what? Product of the numbers. So that is a what? A relationship between the what? LCM and HCF. Any doubts regarding this? Question is, sorry, formula is very simple, children. You can write directly also H into L. You can write as P. H means HCF, L means LCM, P means product. HL is equal to P. Otherwise, P is equal to HL. Like that also you can write as. Clear, children, everyone? Okay. Children, once look at this condition here. LCM of A comma B into HCF of A comma B. We can write as what, children? A into B. Children, from this what I can write? I can write as LCM equal to, how I can write? Product means A into B and this is HCF. Next one, HCF. How we can write, children, here HCF? I can write as A into B and divided by LCM. So if you miss any number or any value, so we can bring that value. Here LCM is unknown, so we can write as A into B by HCF. Here HCF is unknown, we can write as A into B by LCM. Clear, children? It is a relationship between the LCM and HCF. See, children, any doubts regarding this relationship between LCM and HCF? It's a very, very simple, children. You can do your own also. But try to remember, children, like shortcut form, you can write as HL is equal to P. H means HCF, L means LCM, P means product. Clear, children? Fine. Now, children, what we have discussed in this class, it is actually a recap. So, today we have discussed about the introduction of HCF, isn't it? Next, we have discussed methods of finding HCF. So, how many methods we have finding the HCF? And what are those three methods? Tell me, children, total how many methods we have total? We have exactly three methods. But first method, second method, you don't need to learn, children. You have to learn only a third method. That is what? Long division method. Okay, go for third method only. Next one, children, we have learned about the relationship between the what? LCM and HCF. So what is the relation, children? HL equal to P. Okay. So it is the what? Relationship between the LCM, HCF and product. And we have discussed some questions, children, related to what? Finding the LCM or HCF, HCF and the relationship between the LCM and HCF. Clear, children? Any doubts today's class? Okay, so this is actually we have discussed today's class, children. Introduction of HCF and methods of finding the HCF and LCM and HCF and some question we have discussed. Okay.